Hey everybody, we are back from Europe, back from our hackathons, and ready for a little bit more future data. You ready, Johnny? Oh, muted, unmuted,
Unmuted.
unmuted and ready. Cool. Well, today we're gonna go and give you guys a recap of everything that we did over at ECC over in Paris. So today's episode will be around decentralized AI as well as ZKML because we did a lot of cool learnings over there and ways to go and see, sort of like where the space is going. So, to give some context here, I want to talk about sort of what we're trying to achieve with both of these subjects, decentralized AI and ZKML. And for us, we're really focused on the verifiability aspect. It's how can you go and establish trust in a machine learning model? And really, we see sort of three different paths to do it. The first is using computational consensus. And in this scenario, you're actually going to go and use the same data and the same training methodology and have multiple people doing that training to go and achieve the same result. Johnny, is there anything else you would add here? I think you've talked before about using the same seed so that you can actually reproduce this,
Yeah.
right?
So when you initialize, assuming that you have neural networks, when you initialize the neural networks, you should use the same seed and the same type of initialization with so basically to have the same randomness.
Mm-hmm.
And what's important here is that when you run a computational consensus, you use resources, the number of times the nodes you run the process, which can be quite expensive if you train a large language model, for example.
Yeah, like it costs what, $200 million to train GPT-4. So to achieve computational consensus with where three people did it, it would cost three times 200 million is $600 million. A little bit tricky. So let's get into our second method for having a trusted machine learning model over here, which is to do it in a secure enclave. And this is more in line with the computational lineage that we do at Weavechain, right, Johnny? Is this saying that we are running the training process in a secure enclave where we can guarantee what code was run and on what data?
Correct. That is the case. So it's the same computational consensus, computational lineage that we offer for any task, not just for machine learning models. It's having a fully audited read of the data, hashing the model and the output, and chaining them together with a signature, which is a proof of the. There is another step of attestation that you have to do. You have to prove that the process was run in a secret enclave.
There you go. But it is feasible, right? This is like old school cryptography.
Correct. Yeah.
But it still works. Let's say the fancy new stuff over here is this idea of zero knowledge machine learning. And for this, you're trying to go in and package up the computation into a zero knowledge gadget, right? So that you can go and prove what was run. Is there anything else you would say at a brief here?
Yeah, in order to have truly, there are two ways in which you can get the data. You get trust. There is no workaround basically to hashing the input data. So you have to hash the input data during the process. Otherwise, you cannot prove that you run the model on that particular set of data.
Mm-hmm.
And this process can be quite expensive. That's
exactly.
The main issue with ZKML. Also, it's not feasible currently for training. It might be feasible for inference, and there is a lot of progress in that area recently.
Yeah, for sure. And we'll talk about all those limitations in a second. But for now, let's talk about what we did at the Decentralized AI Hackathon Augment over at ECC, where we built out Verifiable, a solution for verifiable AI training lineage. We primarily did this at the Augment Hackathon during ECC. We did win their generalized prize over here. And funny enough, we got connected with somebody at the conference that we just signed contracts with this week to make our first customer, the Proof of Peach team. And I'll tell you a little bit more about what they're doing shortly. But yeah, let's go back to the context here. We want to go and enable the ability to have decentralized trust in the way that these AI models are trained and how they're licensing data. So the problem we're dealing with here is that the explosion of AI has sort of exacerbated issues of fraud and data abuse that we can actually solve for now. So in a world of bots and misinformation, we actually have the power to authenticate sources and identities. And as AI is driving more complex decisions, we can create an immutable lineage of what these AIs were trained upon. And if AI is going to go and learn for us, we should have an owner's right to say no to that, or to get compensated for our data being used. We believe in these properties at Weavechain. You guys have heard me talk about this many times. We want to go and treat data like a first-class citizen and make it so that the data is both verifiable and exchangeable. So for verifiable at the hackathon, we used it to build a framework where we would have a publisher that would bulk upload notarized data and set fees for an AI model to train on it. We were doing Blogger AI here. So imagine somebody taking their entire body of work from Medium, for example, and upload it for usage. Now, wallets are established for each one of the authors from that publisher to receive compensation. And we'll also show through our UI how an independent author could go and license their work. Now, the security of magic of Weavechain is that we can do things like notarize the source data to prove its origin, anchor hashes of that data to a blockchain like Polygon to prove immutability, and use Merkle trees to enable checking if a piece of content is in the data set. We also used locality sensitive hashes so that the data could be missing a period or quotation mark and still match. But the key thing here is that our AI owner, Blogger AI, can pay license fees to then train its model on verifiable data. So we'll walk through each of these steps really quickly. And the first one is, what does it mean to establish notarized source data? So once our publisher, Blogger Data AI, goes and establishes their environment, what we're going to do is have them run a compute task for downloading the data using open source code that can be audited. And Weavechain goes and creates hashes of the Docker image that had the code running inside of it and signs those hashes so that others can validate that the output came from the same code. And the last part of our process here is that we create a bunch of custodial wallets for each of the authors in our data set. Now, the next thing we do is actually go and set fees for the AI model to train on that data. And Weavechain makes this as easy as doing a simple API call to update fees over here. Next, we went and built a UI for verifiable to showcase what an end user single author would have an experience for submitting content to be licensed. So the idea is that writers can come in and choose to submit content to a hungry AI trainer and enter in their content knowing that they are licensing it with full control of its use. Now, everything that the AI does with their data can be verified after the fact. So the data set that's available to the AI model is hashed and anchored to the blockchain. This makes it so that we have these immutability guarantees of the data that's there. And we also create Merkle trees from every piece of content for inclusion checks, where the root hash is also stored on chain for immutability guarantees. With this foundation, our Blogger AI can pay to train on verifiable license data. So just like the download step, we're going to call a verifiable Docker task to train our model using the exact same pattern that we saw. The Docker file runs a shell script that securely reads data via Weavechain to actually feed the model and then trains. Now, Weavechain actually managed the payments based off the fees that we set earlier in a seamless way. So we just paid $400 to go and train on a big data set that is split evenly amongst the authors. And if we refresh this UI, we see that we also got paid. And the key thing about Web3 is that we can't just trust that everything happened as we claimed. We need to be able to verify what happened. So over here in our model, we can come over and see the hashes that we created during this process, and check that the content hash of the Merkle tree. And then over in the UI, we can go and paste in our content. And here we see that, the Merkle leaf exists in a valid Merkle tree, and that its root hash matches what we had anchored into the Polygon smart contract. The last bit that we did, which was for fun, were to use locality sensitive hashes to enable what we called fuzzy matching. And the idea is that we want to make it so if you use slightly adjusted content where you remove a few periods or quotation marks, that the locality sensitive hashes would match even if the text is not. So we were really excited by what we built here. Everything works, which is always a plus if you're doing a hackathon. Making it to that last step is always tricky. And the next steps for us were really to just go and start talking with more trainers and tuners. And that's how we went and found the team over at Proof of Peach. So a lot of their content was actually image data as opposed to text data that was used to train a LoRa model. And again, we want to make it so that that data can be properly licensed. Additionally, we think that anybody that's going to be using this data needs to have a really tight framework for accepting submissions and then deciding what they want to use. And ideally, you would actually have programmatic filters to do that. So if somebody went and submitted a picture that was just, all black, you could go and throw that out without even spending any time looking at it. And same for payments. Like, we did a very simple payments model where everybody's paid a flat fee up front. But ideally, you actually pay people a percentage of revenue on usage of those trained models as opposed to on training. And Richard Agavira pointed us at a really cool new tool called Retrieval Augmented Generation that would be really useful for this specifically. Also for anything that was really serious, like, ensuring who the real owner of an article is an important thing. Like, what if I went and copied the text from your article and submitted it as my own? We'll have to go and do some fun things around dibs and other things to go do that. But it was great. We were really thrilled with what we built during the hackathon and excited also to win a quick award over there. So let's say that this was a really good exercise to go and show, these first two things, how to go and utilize, let's say, secure enclaves that have the Weavechain nodes running inside of it, and also how like Weavechain nodes could be doing that training across multiple nodes to achieve that computational consensus. But let's dig a little bit further into, ZKML and how people think that this could be the future of this kind of trusted machine learning. So the trick with ZKML right now is that it's just not like feasible from a performance perspective. So we have a ton of respect for the guys over at Modulus Labs. They put out a really good paper in January this year that went through a detailed exercise of using like the best sort of zero knowledge proving systems out there and comparing what they looked like if you were going to go and try to run some ZKML gadgets on them. Actually, Johnny, maybe before I talk about the performance benchmarks, we should talk about what's actually happening here, right? Let's go to the blog article that Kobe from Geometry pointed us in the direction of, where they wanted to go and authenticate that, let's say, audio adjustments were done in a way that was not like a deep fake or a hack, but more of something that was done deliberately by a trusted party. And I think that the key idea over here is that if you had an attested microphone that had a public-private key pair associated with it, that you could do, what was it, a ZK snark to go and create a signed version of the original audio, and then a ZK snark to go and do the edited audio over here. Am I understanding that process correctly?
Yes, and it's multiple parties that are signing the source. Or in this particular case, they sign the audio with their Ethereum keys, and then there is a gadget that combines and checks the signatures.
Yeah, exactly. And that's this gadget right here, right? This is the complex ZK code that was built to go and take a bunch of recordings, remove background noise, combine them, and then create some final audio. I guess you pretend like this is for like a podcast, right?
Correct.
And so please go ahead.
In this particular case, the source of the data is trusted, so the data is hashed and signed. It's similar how it actually also Weavechain does this from when writers are producing data that is sent to the nodes. So it's a similar process where the individual recordings are trusted because they are signed by their Ethereum wallets.
Yeah.
So
it's hard to go away from hashes and signatures, right? They're a critical part of all these trusted processes.
Yeah, and this gets the signatures and the hashes are trusted, and then there's a gadget that combines them in a trusted way. So you can trust the result because this gadget is doing it in a provable fashion.
Now, in this case, this is not a machine learning process, right? This is just a process to remove background noise.
Correct. Yeah.
But this is the core idea is that you need to go and encode the gadget for doing specifically what your operation is over here.
Exactly.
And
So
this is where go ahead.
in the ZKML case, you actually need to code the whole inference of the model. So you basically need to write the neural network evaluation as a ZK proof gadget.
Exactly right. And this is where we start to go and see some pretty high levels of complexity and overhead, both in the coding and the actual results over here. So, they went and did benchmarks using a lot of different zero knowledge proofs over here to go and see how things performed. And, the TLDR of this, from what I saw, was, first off, like, it was prohibitive from a memory usage perspective. Things got really out of hand really quickly. And then also it was so challenging from performance perspective that really they were just using it for inference from a trained model as opposed to the actual training of the model itself. Anything else that you would add to this, Johnny?
No, I think you covered it perfectly. So currently it's only the inference phase, and the performance is not quite okay. Worldcoin is the best example here with inference.
Yeah, maybe you could give a quick brief on what they're doing. But the WorldCoin guys, they're not they want to use ZKML long term, right? I know they have their awesome ZKML repo over here, but they're not using it yet, if I'm right.
They are not using it yet. So right now they use a secure enclave and some checking mechanism in their hardware devices. They run a NVIDIA Jetson. They run the inference there to process the inputs. They have, I don't know, visual and infrared, I think.
Mm-hmm.
And
maybe I could just give context really quickly for anybody who's not following what's going on with WorldCoin right now. WorldCoin is a company that was founded by Sam Altman, who has also done OpenAI. And the idea is to go and give users a proof of personhood ID that shows that they are a human being and not a robot. And to do that, they utilize these orbs that will go and let's see, can I go and see the front end of this thing? There we go. Let's see if they have it in the video. This orb will go and, take a super fancy picture of you as a human being to go and validate that you are a human. And that super fancy picture is going to go and do a super intensive retina scan of you as a user, as well as take a 3D model of your head to go and see what's going on. See if they can find it. And then, on the thermal part of things, I cannot find anything besides what looks like a lot of doomsday stuff over here.
Maybe the hardware specs on their GitHub.
Oh, perfect. Let's see. Orb hardware. Yeah, so it's like a super fancy camera inside of this orb that's doing a really deep retina scan of the user, a thermal check, and then a 3D face check to go and identify your person. Now, when they do this really intensive check, it's not like they're taking all that information and storing it in a database somewhere. The thermals and the 3D model are to make sure you're a person and not a picture. And then the retina scan, it's not like they're even taking the entire retina scan and putting that in a database. They're actually creating a really interesting hash of your retina so that they can always prove that you are in the database, but they can't go and recreate your retina data in the future to be spoofed against. And that mechanism for creating that hash is what we're talking about here as something that they want to use ZKML for in the long term, but are actually using a secure enclave for in the short term.
Yeah, and it's a convolutional neural network that is running and producing that hash right now. Or we can call it hash, or I don't know, some numbers in the output.
Yeah, let's go with a hash for now. But I think right over here is where they're taking the biometric data and calling this function to go and create that really fancy hash, which is what they go and put in their database in a way that hopefully maintains users' biometric privacy as much as possible, but still enables this validation of personhood. Now, this is a very long-winded way of talking about how they're actually using, from our diagram earlier, the secure enclave method until ZKML is ready, right? Until ZKML can go and take care of these issues that we've seen over here. And, WorldCoin is one of the more advanced organizations. If we go back to one of the slides I had earlier talking about the regulation in New York that's forcing companies that use AI models for hiring decisions to prove that their models are not sexist or racist, companies that are trying to do that right now actually go old school and just hire a consulting firm that will go and audit their code to go and show that their processes are using models that are not biased, right? It's almost like an old protection money scheme where you have to go and prove that you have paid the right people to go and do the right checks on you to go and ensure that you have done things by the books. Our hope is that things like trusted ML computations and ZKML can obviate these manual processes, but we're still a long ways away. It was really exciting, though. I think understanding these different things that are coming up are really cool, and understanding how blockchain technology can combine with AI is really exciting. This concept of trusted machine learning, I think, is going to be something that we hear about more and more, and we're excited to dig in here further, and hopefully we'll have a case study to share with everybody on our first customer soon enough. Well, Johnny, I think I can let you go from here. But thanks again to everybody for all your support throughout the hackathon, and looking forward to chat with you about the future of data again soon.
Bye.